Bismillahirrahmanirrahim. This video is from DLD chapter number 4, book by Mr. Moris Mano. And here we'll be discussing analysis procedure for this a student has requested. So let me explain two things that we'll be talking in this chapter. Actually, one thing, that is the combinational circuit. So what is a combinational circuit? The definition says the diagram of a combinational circuit has logic gates, only logic gates, with no feedback path. Like in this diagram, you can see there is a feedback path. So nothing in the combinational circuit, or memory elements. Like in this diagram, there's a flip-flop, but in the combinational circuit, there is no flip-flop. It is just the logic gate. And the circuit with feedback and memory elements is called actually sequential circuit, which we'll discuss in subsequent videos. Okay, now what is analysis? It means if you just take a crude example, if we want to know what is inside the motor, then we have to strip it open and then you can see all the components. So analysis, we can say, is just like going into much detail of the things. And now we start with the logic diagram. This is the logic diagram. And we culminate with a set of Boolean functions. So the output should be either a Boolean function, or it should be a truth table, or there could be some kind of a written explanation of what is the output. Now, in this case, you can see this equation relates to output F1 and the other one relates to output F2. So this is what we get after analyzing this circuit as output F1 and F2 in terms of the input variables ABC. Now, let's explain the circuit. We note that the circuit has three binary inputs, ABC, and two outputs, F1 and F2, these two outputs. Now, from the diagram, we can straight away write this equation for F2, and let's see how. This AND gate, the output of this AND gate will be A, B, or A and B, like shown here. Then the output of this one will be AC, shown here, and the output of the third AND gate will be BC. Now all three outputs of the AND gates are then fed into an OR gate. So because of the OR gate, the output here, which is F2, will be with plus sign. So this gate plus sign the second gate plus sign the third gate. So this is the output equation for F2 output. Now we have to find F1. From here you can see this is an OR gate. So T1 we can write is to be A or B or C. And T2 is connected with an three-terminal input AND gate. So it can be written as T2 is equal to A and B and C. Now, what about T3? T3 has two inputs. One is T1 and other is F2 dash. Now, this is F2. After the inverter, this will become F2 dash. So T3's output will be F2 dash and T1. And so F1 now will be this T3 and T2, and this is connected with an OR gate, so we'll put a plus sign. So T3 plus T2. So this is the output. But you can see F2 is in terms of the input variables A, B, C, but F1 is not in terms of input variables. So we have to make some calculation to bring this to the shape of ABC. So we start from here and then plug in the values of T3 and T2. So T3 from here is F2 dash T1 and T2 from here is ABC. We have to further split T1. So putting the value of F2 dash and T1. Now F2 is this term. So we'll write that and then put a dash. And then T1 is ABC. So we write ABC in the bracket. And now if you recall, how do we open a bracket which has an inverter? We change the sign and also the variable gets dash. So this will be AB dash. This plus will be replaced with the and or a dot, then AC dash, and then dot BC dash. This will remain as it is here. And now we can further open this. Then because it is AND gate inside, it will now become OR gate with A dash and B dash. So this is what it will change. A dash or B dash, similarly this one, and these two remains as it is. So this needs further simplification. So we'll move to the next page. But before we go to the simplification, remember table 2.1 has a couple of postulates and theorems. So I'll be using these three that I have marked here, like x dot x dash will give a 0, x dot x will give an x, and x plus x or x or x will give an x. Okay, so we were here. Now we just multiply these two, we get this relation. Then we'll multiply with B dash, C dash. So multiplying with this, we get these 8 terms. ABC remains as it is and plus ABC. And now here we can use the formulas. So we'll use first formula, x dot x is equal to x. So wherever we have two variables same type like A dash, we'll just write one of it. So this will be A dash, B dash. No change here. Here it will be A dash, and because of two B dashes, we'll just write one. So this way you get this equation. Now further, we'll use this relation that if there are two of the same with the plus sign or OR gate, then we can write just one. So let's see here, A dash, B dash, A dash, B dash 2. So we'll just write one. And similarly, the other terms. So the duplicates I have crossed. You can check them. So what is left is this, and then multiply by A plus B plus C and ABC. And now we'll multiply each with A, this bracket with A, then B, then C. So multiplying with A, then multiplying with B, multiplying with C, and the last term remains as it is, plus ABC. Another formula, if there are two multiplication of x and the complement of x, then the answer will be 0. So let's see. Here you can see A and complement of A, therefore this will be 0. Similarly, you can identify like here B and B dash, so this will be 0. So all those that come up to this criteria will cross them. So this cross, all the crosses. And so what is left is these 4 terms. And we just write them in neat manners. So ABC, so this is the answer for F1. So our final answer will be F1, this value, and F2 we had already found. So this is the answer. And therefore we can say that for this circuit, the answer or the output is as shown here, F1 and F2. Okay, as we have mentioned that we can write the answer in terms of a Boolean function, or we can write it in terms of a truth table also. So let's see how to write in terms of a truth table. We can obtain the truth table directly from the logic diagram without going through the derivations of the Boolean function. We'll write directly. So let's see how it is done. Okay, so 3 inputs. We have these 3 input written, and for 3 inputs we have 2 raised to the power 3. That means 8 options. So we have written them. Okay, and now we starting from here. So A dot B, A dot B. Now since this is AND gate, the output will be 1 only when A and B are 1. So here is only A, B 1, here A, B 1. So we write 1, 1. The remaining we should have written 0, but just to avoid clutter, I'm not writing, keeping them blank. Similarly, A and C, A and C. You can see it is here both 1 and here both 1. So 1 and 1, and similarly BC. And now F2 is the output of this or together. So in OR, wherever there is 1, we write it, and the output 1 output 1 output. This is all 1 output. So this is the output of F2. So we're writing here, and now we move to this side to find F2 dash. We just invert F2. Wherever it is 0, we write 1. Okay, so we were here. And now to go further, we will just delete this to make it easy looking. So our circuit will look like this, and we delete this one. Okay, and now we'll find T1 from here. Sorry, we have just added T1. And what is T1? We had found F2 and F2 dash up to this point. And then T1, you can see wherever it is OR gate. So OR gate means wherever there is 1, we'll have a 1, 1, 1, 1 all the way, except for the first row. So T1 we have found. And now we can find T3 and T2. So let's find T2. T2 has inputs and its output is through AND gate. So output will be 1 whenever all 3 ABC is 1. That means only here. When ABC is 1, T2 will be 1. Okay, so what is left now is T3 and then F1. So T3, you can see it's an AND gate with T1 and F2. So T1 and F2. And AND gate, so wherever both are 1, only there T1 will be 1. So here, here. So this is T3. And now F1 is T2 and T3 with OR gate. So between these two, wherever there is 1, we'll have 1. So this is F1. Okay, now we have to write the equations. So we can simply write the terms where F1 is 1. So it's 0, 0, 1, which we can write as A dash, B dash, C. Then here it is 0, 1, 0. So we'll write A dash, B, C dash. And same here. Also for F2. So F2, we can check where it is 1. A has to be dash, and then these two without dash. So A dash, B, C. Here it is A, B dash, C, A, B, C dash, and A, B, C. Okay, now let's check with the equation that we already derived in the previous slide. F1, this was the value of F1 we got, and this is the value of F2 we got. So our F1 is same, A, B dash, C here, A, B, C dash, A, B, C dash, and similarly all these. But F2 has a different format than what is given here. Now for this to match, we have to take help of K-map. And so this is the K-map. We have A, B, C. So we just plot A dash, B, C. A dash means 0 and then B, C 1. So there's a 1 here. Similarly, this one, this one, this one. I hope you have learned by now how to plot on the K-map. And now we'll group them to minimize. So these two can be grouped, and you can see this is A is 1 throughout this, and here only C is 1, so AC. So we get this term. The second term is also A, and then we have B. So AB. And the third term is BC. So from here, we get this answer. So I hope you have been able to follow this. Please let me know through your comments if you have any doubt, any questions. Thank you.